In the middle here we have the rotary switch. It's a 9-position switch, very easy to use. We'll actually be running through each of those positions later on. You have 4 function buttons: send, pump, backlight, and also the on-off button. Again, we'll be running through those. These 3 buttons also have a second function: scroll up, scroll down and enter. On the top of the analyzer you have a infrared emitter which will send the information to the printer. There's also an inbuilt torch. On this side of the analyzer you have a socket for a gas leak detector, which is just a plug-in unit. Coming a bit further down, again on the side of the analyzer you'll be able to see a white filter, which is the particle filter. Here we have the water trap, which will take out any condensate to make sure that the sample of gas going to the analyzer is a clean, dry sample. Also on the front of the analyzer is a battery charging indicator, which will be orange when it's charging. If we look at the connections on the bottom of the analyzer, you've got 2 connections for temperature. Now these are T1 and T2. You've got 2 connections for pressure, P1 and P2. Here is the connection for the sampling hose, so that's going to connect to the bottom of the water trap. Here we have the rubber bung, which is the drain plug for the water trap. And finally we've got a connection here for the charger unit. Now that can either be used with a 240 volt charger or with a 12 volt charger. On the back of the analyzer, this is the exhaust port for the flue gases. Here you have 2 magnets to actually attach the analyzer to a metal surface. To change the batteries or to change the particle filter, you must first remove the rubber boot. The easiest way to do this is to remove it at the top and then pull the analyzer up away from the boot. On the back of the analyzer, this is the battery compartment. Just undo the cover and you can get to the AA batteries. Also on the side of the analyzer you can see the particle filter. To check this we need to remove this whole assembly and you can get to the filter. It's actually the middle of the filter that gets dirty first. So if that filter was blocked, dispose of this filter, replace it with a new filter and reassemble. Also, while we've got the rubber boot off, you can also see on the bottom of the instrument these connections are actually marked up as T1, T2, P1 and P2. Just replace the rubber boot, push it in at the bottom, pull it up at the top, and there you go. This is the standard flue probe. On the shaft of the flue probe you've got this adjustment cone, so you can actually gauge how far you put the probe into the flue of the boiler. On the tip of the probe you have a thermocouple, this wire, so that's actually going to measure flue temperature. The cable from the thermocouple runs down the side of the hose to this plug. The actual hose itself has a connector, black connector with 2 O-ring seals. Before using the analyzer, firstly check that the particle filter is clean. Also check that the water trap has no moisture in it. If necessary, gently remove the rubber bung and then replace it. Make sure that there's no water left in the flue probe hose from your previous tests. Connect the hose to the bottom of the water trap. Connect the plug of the thermocouple into T1. Normally if you have the head of the screw pointing towards you, that makes sure that the connections are around the right way. When you want to use the analyzer, the first thing to do is position the flue probe in fresh air. to make sure you're not in an area with any carbon monoxide. Then press the on button. You can hear the pump start. It starts its countdown, briefly flashes up the battery status, the fuel and also the pressure units, and it continues its countdown. On a Kane 425, the fresh air purge normally lasts somewhere between 30 seconds and a minute. On a Kane 455, it normally lasts 90 seconds. When the instrument's finished its fresh air purge, initially move the dial to the ratio position. You can then check that the CO reading in fresh air is 0. Then move the dial to the oxygen and efficiency position. In fresh air, the oxygen reading should be 20.9%. Now that may vary by 0.1% either way, so either 20.8 or 21% is perfectly acceptable. The TI figure here, that's the inlet temperature. When we switch the instrument on, that was the actual temperature of the thermocouple on the end of the flue probe, and the analyzer remembers that temperature as the inlet temperature. Next, move the dial round to the status position. You notice that stops the pump. On the top line, it gives you battery status. If this is lower than 20%, either replace or recharge the batteries. You've got the clock, the calendar, and also on the bottom line, cal, that's the number of days before the instrument's due for its next check and recalibration. When the fresh air purge is complete, move the dial to where it says ratio and check that the fuel is the correct fuel. You can select the fuel via the menu. Having referred to the boiler manufacturer's instructions regarding the position of the probe and also the test procedures, insert the probe into the boiler. Now you'll notice that the readings have about a 10-second delay. This is the time for sample of flue gas to actually travel the length of the hose and be analysed. It is actually continuously sampling. When the readings have stabilised, typically after a minute or so, with the dial in the ratio position, you can check the actual CO2 ratio to 4 decimal places, the carbon monoxide readings in parts per million, and the carbon dioxide or CO2 reading in a percentage. If you move the dial to the oxygen and efficiency position, it gives you the oxygen percentage. TF is the flue temperature reading in degrees C. TI is the inlet temperature, and EFC is the combustion efficiency reading. The next position on the dial is the auxiliary position. This is currently set to show oxygen, CO, the clock and the battery status. But you can actually set via the menu the readings that you want on lines 1, 2, 3 and 4. This is actually your personal page. When the readings are stable and you want to do a combustion printout, the rotary switch can either be in the ratio position, oxygen efficiency or the auxiliary position. Simply make sure your printer's switched on, press the send button. You must keep the analyzer and the printer lined up all the time that it says printing on the display. Combustion readings can also be logged. by pressing the send button for 2 seconds. The log number is briefly displayed on the top line. These readings have been stored as log number 8. The memory can store up to 99 combustion readings. Logged readings can be viewed and printed via the menu. When you've finished your combustion tests, switch the instrument off and it will automatically go through a 30-second purge cycle to make sure there's fresh air in the analyzer. When you finish your combustion test, disconnect the thermocouple and the flue probe hose, wait for the probe to cool, and then move the adjustment cone over the tip of the probe to protect the thermocouple. Because during the tests moisture will have collected in the lowest point of the hose, it's important to actually wind the hose up so that any moisture drains out. If we just put the probe on the floor and then just wind up the hose so that any moisture drains out. Be careful because that will be slightly acid. To use the analyzer as a pressure meter, first move the rotary switch to pressure. You notice that the pump stops. At this stage, don't have any hose connected to the pressure meter. Press the pump button to zero the pressure meter. Now you notice on the display it has pressure to 2 decimal places, reading in millibars, and you have a clock so you can actually manually time a test if you wanted to. What we're going to do is actually set a burner pressure as per the manufacturer's instructions. So we've zeroed the pressure sensor. I can now connect the hose to P1. It's already connected to the boiler. Now I can fire the boiler. Just wait for the pressure to stabilise. So here we've got a pressure of 7.3 millibars. On this particular boiler, the manufacturer's instructions say set the burner pressure to 6.9 millibars. To do this, you adjust the regulator screw anti-clockwise to 6.9 millibars. Having set the burner pressure, I'm now going to use the optional gas leak detector to check that the test point is gas tight. To do this, plug the gas leak detector into the side of the analyzer. The analyzer just acts as a battery pack. Switch the gas leak detector on. It takes approximately 20 seconds to self-calibrate. So I'll just turn the boiler on now. When it's finished its calibration, the green light stays on, which means that the battery power is sufficient. The amber light pulses, and there's also an audible tick. If we now move the head of the gas leak detector to the test point, we can see there's no speeding up, therefore the test point is gas tight. Tightness test. Select tightness on the rotary switch. The pump stops and it tells you to press the pump button to zero the pressure sensor. When you do this, make sure you have no hose connected to the analyzer. It asks us if we want to do a let-by test. Use either of the scroll buttons to change that to yes, and then press the send button or enter So it's now ready for us to connect the hose. I've connected the hose from P1 on the analyzer to the test point on the pressure meter. I'll now increase the pressure to 10 millibars. When the let-by pressure has been set to 10 millibars, press the send button to start the test. P1 is the pressure at the start of the test. P2 is your current pressure, and the instrument automatically times the test for 1 minute. This can be changed via the menu. As the instrument gets to the end of the let-by test, check the figures to make sure that there is no let-by. If you're happy with the let-by test, you can then continue to the stabilisation. Now set the stabilisation pressure to 20 millibars. When the stabilisation pressure has been set to 20 millibars, press the send button and the instrument automatically times the stabilisation for 1 minute. Again, this can be adjusted via the menu. When the stabilisation test has completed, press send to start the actual tightness test. P1 is the pressure at the start of the tightness test, P2 is the current pressure, and again there's an internal clock to time the test for 120 seconds. That time can be adjusted via the menu. The tightness test has now been complete. The results have been logged in the memory as test number 1. The initial pressure was 19.97 millibars. The final pressure after 2 minutes was 19.86 millibars. So on this installation there's been a pressure drop of 0.11 millibars. To print the readings, press the send button with the instrument pointed at the printer. To test ambient CO levels, move the dial to the room CO position. When you want to start the test, press the pump button. The pump starts and the analyzer continuously measures CO. It records the highest CO level that it's seen during each minute. The test can last up to 30 minutes. The operator can actually stop the test any time during that 30 minutes. The results are automatically logged into the memory so that you can print either at the end of the test or later from the memory.